to the steel bleaches. And in Japan or in the world, we have the weathering steel bleach or mild steel plus paint. We using the steel materials for bleaches. And when we thinking about the deterioration of the steel bleaches, there is a fatigue and corrosion is the main reasons. And I focusing on the corrosion deterioration. And so when we would like to check the deterioration level of steel bleaches, how to check it? Usually we doing the inspection by the human eyes and close to the bleaches. And nowadays we using some robotic technologies such as drone or any robotic camera. And for example, in Japan, we have the criteria of the weathering steel bleaches, the corrosion level. It is based on the rust thickness and appearance and the appearance introductions. So for my research motivation is to confirm the multispectral imaging method ability for classifying steel corrosion deterioration as a simple inspection or monitoring methods for steel structures. Because usually we are doing the inspect by ourselves, so it is really takes the time. So we try to reduce such a cost. So I focusing on the multispectral image, multispectral camera. So in order to achieve this goal, I have these 3 steps. And in today's presentation, my research target was the Griffith University's foot bleach. And this research is a collaboration with the Professor Hongwan in Griffith University. And this bleach is foot bleach, and it's constructed by steel box girder, which means it has a steel deck as well. And for corrosion environment, it is about 3 kilometers to the west southport. It's close to the sea, and also that is humidity and temperature. In Gold Coast is red, and Ube City is my university's city in Japan. I guess it's not too big difference, but in Gold Coast is more humid in whole years. It means the for corrosion, it's a little bit severe than Japanese for my university's place. And I use this multispectral camera. It was LED lights in close to the lens, and it is focusing on the near IR, near infrared area, and it has the 10 bands from 713 to 920, and the range is plus minus 10 nanometer. And today's presentation is just a trial at the actual bleaches. Now I am doing the same research for the specimens, so I will check it as well. And it is the procedure of taking picture and the analysis. Using multispectral camera just gets such a grayscale image, only grayscale images. So I need to use RGB camera, just the iPhone or any other camera, and to take RGB image and also multispectral camera image to compare both of them. And as seen the right top, when we check the RGB images, we cannot see the big differences. But when we do the multispectral imaging result, it looks like difference. So the details of the multispectral analysis to get multispectral imaging, as I said, the multispectral output is only the grayscale images. Then just selecting analyzing area and white reference area, then calculating each pixel's reflection intensity ratio based on the white reference, then mapping by each one. This picture shows the 713 nanometers bands examples. And as see this area and that area, we can see the reflection intensity ratios averages differences in the area. So, and it is depends on also the bonds number as well. When we check the on the RGB images, we cannot see the difference. But the 713, we compare the blue and green one. And if we check the 920 nanometer, which means the higher NIR bands, it's also differences in green with red. So in order to, oops, sorry. Oh, the movie is not working. So I'd like to check what is the, oh, sorry, it's not working maybe. It's okay. It's just checking the last thickness. So because of the, we don't know what is the differences of the multispectral imaging color differences. So I check the last thickness of collision area and to compare with the multispectral imaging results. So this one shows the compelling result. I take multispectral imaging in 4 areas, and I got 16 points results. And as we can see, there is no trend, I think. But when we check on the each point, which means I said that I take pictures on 4 points. So I divided into 4 points of the result. So in that case, not too much, but a small relationship between last thickness and reflection intensity ratio. If last thickness is higher, its reflection intensity ratio is smaller. And when we're focusing on the first one, as we can see, it does have some differences. But for example, in such the top two, it's too brighter, I think. And compared with that, the downside is too dark. So when I taking the multispectral imaging, I feel the LED light is quite weak to take the images. So maybe it's required to more bright light. So this is my conclusion. So as I said, it is a first trial to take multispectral imaging in outside. So as a result, multispectral imaging can be obtained from actual ledge surface, but in this time, just checking on the deck. So I will check in the web or front as well. And there is a small trend between reflection intensity ratio, but it is only the same multispectral imaging. So as a future work, continuing comparison with other parameters, for example, surface roughness, amount of chloride, RGB, etc. So this is end of my presentation. Thank you for your kind attention.
Thank you very much. Do you have any questions for Rina? So just a quick one from me. Who funded this research? Is there any industry partners involved in this? Yep.
How to say the fund from the where? Not the industry, just the funding from Japan.
Right.
Yes.
Right. Excellent. Thank you very much. Thanks for your presentation.